Okay, we're going to go ahead and get started. This is lesson 23, and we're working with angles, where this is our first chapter that we're going to be looking at trigonometry. So from here on out, we're working with trigonometry and angles, mostly angles, triangle, trigonometry. It touches on a little bit on the unit circle, but not a whole lot. So to start with, we have basically the definition of a line where it continues on through infinity in both ends with distinct points in it, whereas a line segment ends at 2 points, has a beginning and an end. So that's the difference between a line and a line segment. Whereas a ray has terminates on one end, but it continues on infinitely in the other end. And we distinguish 2 points on that ray. So rays are going to be important for what we're going to be looking at, because angles is basically the measurement between two rays that are joined at a common point or a vertex. And so the rays are, of course, going to be the sides of the angle, where you have a terminal side and you have a side that where the angle begins at. And so an angle, basically, if we're looking at, we always start with an angle starting from the right and going in a counterclockwise direction, usually, especially on the coordinate plane, or when we're talking about the unit circle. And so we have an initial side, and then we have our terminal side. And so the initial side is always to the right on the unit circle. So here you can see that it moves in a counterclockwise direction, where you always have the initial side in the same place, but the terminal side will change position, and that's where the angle ends at. So it doesn't have to be in a acute angle, and an angle can continue on, an infinite many number of times. So this would be considered a positive angle. And then from the initial side going in a clockwise direction, that would be a negative angle. So we could say that this first angle, we could say that this first angle, we could say that this first angle could be like 300 degrees, positive 300 degrees, whereas this second one here, that would be considered like a negative, let's say negative 50 degrees, and so on. Most common unit of measure is the degree. And one complete rotation around, where the initial side and the terminal side come back completely around, is 360 degrees. So 1 degree, that would be, of course, 1/360th of that. An acute angle is anything that's less than 90 degrees but greater than 0. And then we have a right angle. Notice we have that perpendicular looking symbol. Obtuse is anything greater than 90 but less than 180. And then a straight angle, that's a complete 180 degrees. And you would think, well, why don't they just call it a line instead of a straight angle? Well, because there are times when you have two angles that add up, that are in conjunction with that with the two angles added together give you this straight angle. So there is some functionality to having a straight angle. For an angle measuring 40 degrees, find the measure of its complement and its supplement. So here we want to look at the complement is always going to have two angles that measure up to 90 degrees. So if we subtracted 40 from 90, the complement of 40 would be 50. Whereas two angles added together add up to 180, you would subtract 40 from 180. And so 140 and 40 are supplementary angles to each other. So we could say that the supplement of 40 degrees is 140 degrees. So here we have two angles. Find the measure of each angle marked, and notice we have that. When you see that box looking similar, you always know that that angle is how many degrees? Sydney? 90 degrees, right? These two sides are perpendicular to each other. And so if we take these two angles and add them to equal to 90 degrees, we can see that x would equal to 10. So that would be 60 times 10. 6 times 10 is 60, and 3 times 10 is 30. So these angles would be 60 and 30. Okay, now how many, we would take these two angles here, 4x and 6x, and we would add them equal to what? Dylan? Well, if we look at this straight line, right, we said a straight angle is 180, right? So if we look at these two angles together, they add up to 180. That's right. So that's where the functionality of the straight angle comes in, is the two angles together add up to 180. So that would give us 18. So 4 times 18 would be 72, and 6 times 18 is 108. All right, now let's say that we had an angle such as that. And one angle is, let's say this is 100 degrees, or this would be 10x, and let's say this would be 8x. Again, you can see that no matter where they're at, here we have a straight angle, whether it's, it doesn't have to be just one line and then a line and a ray. It could be two intersecting lines, and they could even be lines that, no matter where they're at, on these intersecting lines, as long as you have that straight line or that straight angle, you can look at this as the two angles that are supplement to that would add up to 180. Okay, so sometimes people don't always see that you can do that. All right, questions with that? Okay, next we have degrees, minutes, and seconds. So we know that 1 degree is equal to 60 minutes. So this dash looking figure, that's means that's the symbol for minutes. So if we were to look at, for example, if we took, let's say this was 1 degree. Now we took that and we blew it up, and that 1 degree has 60 minutes in it. Kind of like 1 hour has 60 minutes in it. Think of it that way. Now if we took that 1 minute and we blew that up, that would have 60 seconds in it. So just like on a clock where there's 60 seconds in a minute, 60 minutes in an hour, well, the only difference is instead of hours, we're talking about degrees. So if we took 1 degree and we multiplied that times 1 over 60 minutes, and we multiplied that. So if, in other words, 60, if we took 1 degree, we have 60 minutes in 1 degree, and there's 60 seconds in 1 minute. So we could say that 1 degree equals to 3,600 seconds. So that's where this 1 degree equals to 3,600 seconds comes into play. All right, questions with that? So as long as you know this, breakdown on our units, you can use a unit analysis to work through the problem. For example, if we have something like this, let's say that we wanted to convert right over here, 74 degrees, 08 minutes, and 14 seconds. We want to convert that into decimal degrees. We could say 74 plus, and here we could just, we don't need 08, we can just say 08, give yourself some room, plus 14 seconds. And so we can say that since we know that 1 degree equals to how many minutes? Travis? 60 minutes, right. So basically we can convert this to, we can say either 1 degree equals to 60 minutes or 60 minutes over 1 degree. Well, when we're using unit analysis, we want the units to cancel. So in this case, this would be 1 degree over 60 minutes, so that the minute units cancel. And that's how you can tell whether you're multiplying or dividing the 60. All right, now we also know that 1 degree equals to how many? We're looking at seconds now. So 1 degree equals to how many seconds? Harley? 3,600 seconds. So we want to ask ourselves, do we want to use 1 degree over 3,600 seconds or 3,600 seconds over 1 degree? So we want the seconds units to cancel, right? So we would use the 1 degree over the 3,600 seconds so that the second units cancel. And so on the calculator, you're going to get 70, this is degrees here, 74 degrees plus 8 divided by 60. That's going to give us 0.13333 degrees plus 0.0039 degrees. So all of them added together is going to give us 74.137 degrees. Rounded off to 3 decimal places. All right, questions with that? Now these may repeat. Do they? What did you get, Harley? Did you try it on the calculator?
I got 74.01.
Okay, try it again some other time. Okay. So now let's say that we want to come back to this. Now let's say we want to convert from degrees to degrees, minutes, and seconds. All right, so here we have, for example, we have 34.817 degrees. Well, you're going to have your whole 34 degrees plus the 0.817 degrees. And what we're going to do is we're going to multiply that times 60 minutes. Because, again, remember we had 1 degree equals to 60 minutes. So are you going to use either 1 degree over 60 minutes or 60 minutes over 1 degree? Well, since you want the degrees to cancel, we're going to use the second one so that our degree units cancel. And so when we do that, we're going to get, here's 34 plus 49.02 minutes. Okay, well we don't want any decimals. So we expand that further. And we use 34 plus 49 minutes plus 0.02 minutes. And we know that there's 1 minute equals to how many seconds? Well, how many seconds are in a minute? Travis? Right, 60 minutes. So we're going to multiply this by 60 seconds over 1 minute so that the minute units cancel. And so we get 34 plus degrees plus 49 minutes plus, from there we get 1.2 seconds. So we're going to round off to the nearest second. So that's going to make it, excuse me, that's going to make it 34 degrees, 49 minutes, 1 second. And that's our answer. All right, questions with that? Okay, to continue on, we have an angle is in standard position if its vertex is at the origin and its initial side lies along the positive x-axis. So again, here's our coordinate plane, x-axis, y-axis. We have our initial side, our terminal side. The first quadrant is you have both positive x and y coordinates. And then you have the second quadrant is after 90 degrees but before 180. And then you get the third quadrant and then fourth quadrant. So the coordinate plane is broken up in the fourths, quadrant 1, 2, 3, and 4, going counterclockwise. So we can say that if we're looking at our coordinate plane, we have, this is x and y, we have angles 0, 90, 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then so we're going on around this way, and then 0 is also 360 degrees at the same point. I mean, you have to go all the way around to get to 360, but your circle ends up back in, your coordinate plane ends up back in the same, or your angles end up back in the same point as 0. And so this would be quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So these would also be known as quadrantal angles, where they lie right on the x or y axes. And so if we could keep going around and around and around indefinitely, and each time we go around we could consider them coterminal angles. So here we have an angle that's 60 degrees. It goes from 0 to 60. But then if we were to keep going a complete 360 degrees, we could say that 360 plus 60 degrees, that's going to give us 420 degrees. So we could say that 60 and 420 are coterminal angles, because they share the same terminal side. And here's another example where we have 110 degrees, and then here it goes 1 time, 2 times, and then not a complete third time around. So we could say that 360 times 2 is how much? Well, 2 times 36 is 72, so this has to be 360 times 2 is 720. So this would be 2 times around, 360, 720. And then 720 plus 110, and that's where you get the 830 from. So we can say that 830 and 110 are coterminal angles with each other. We could also say if this is 60 degrees here, we could also say we could go the other way and say that if we go clockwise, that would be a negative 300. Well, how do we know that? Well, if we took 360, or negative 360 plus 60, we get negative 300. So again, when an angle goes in a clockwise direction, the angle is negative. So we can also say that 360 are also coterminal angles. So you can have coterminal angles going in a positive direction, you can have coterminal angles going in a negative direction. So technically, you could have an infinite number of coterminal angles, because you could keep going around and around and around and around with it. Okay? All right, questions with coterminal angles. And here's another example of a negative 75 degrees is what we're starting with. And we took 360 plus 75. So basically we're subtracting, and that's coterminal angle that way. All right? But we could also use a negative 360 plus a negative 75 like that. Okay? And that would give us 5. And 435. 430. So we could also continue on around, and we can say a negative 435 degrees is also coterminal with negative 75. So one of the problems that's asked is to take an angle and determine one positive and one negative coterminal angle from that. So let's take a look at that. So let's say here we have a negative, let's say we have a negative 159 degrees. And we want to find the measure of two other angles, one positive and one negative. Okay, so basically what you're doing here is first you add, no matter what the angle that you're starting with, first you add 360 to it. And so that would be basically 360 minus 159, right? So that would be 1 and then 0, 201. So there's your positive angle. And now for the negative, you just take 159 degrees minus 360. And so now basically we're adding negative 360 and a negative 159. So that'd be 9, 5, negative 519. Okay? And so that's how you do that. No matter what angle, but whether you're starting with a positive angle or a negative angle, you just add 360 to one of them and then subtract 360 from the other, and you get your positive and negative angles that way. All right, questions with that? Okay.